Hello and welcome to the final session in the Python and 10 lunch break session. I'm just going to share my screen here and we will get started. Okay, let's switch this out. So again, we're going to do bite-sized guides here to finish up with lessons 9, 10, and then a little bit of a bonus. So on lesson 8, last time we tackled data transformations. Now we'll go into the wider world of Python add-ons. We'll look at Python modules, packages, and libraries. And the 4 different kind of steps we'll do, or 4 different examples, is built-in add-ons 1 and 2, and then third-party add-ons 1 and 2, looking at a variety of different either modules or packages. So with that, let's do some definitions here of what I would say add-ons are. So there's the module, and modules are simple Python files that contain collections of functions and global variables. It's really just code grouped together according to a particularly defined function or purpose. And so modules are fairly simple. And in fact, of course, you could write a couple functions and call it your own module. Now, a packages is the next level up. It is a simple directory that contains collections of modules, and they're compiled pieces of code created by some sort of third party to automate common tasks. Finally, the highest level, libraries are collections of related reusable chunks of code that are imported and called with methods as needed. There is a standard Python library that comes with your Python. That includes function, classes, objects, data types, etc. But then, of course, you can add additional libraries. So the take-home point when we use these different terms is a module is a collection of code, of Python code. A package is a collection of modules. And a library is a collection of packages, strictly speaking, or broadly speaking. And for more information, you can take a look at these resources. I'm by no means an expert on add-ons, Python add-ons, but I've worked with them before. Okay, so how do you get add-ons? Well, Python has some built-in add-ons, so we don't need to, we'll do that within the script. But if you want to do third-party add-ons, you're going to actually have to go to a text-based interface to install add-ons. So it depends. So it's commonly called the command line. So there's slightly different names. In Windows, it's often called the command prompt, and in Apple and Linux is typically called the terminal. So to do that, you can kind of go to your search bar. So I'm in a Windows, so I'm going to search for command prompt. Pull that up. So it's here. And again, if you have different operating system, you'll use something differently. You can do a lot of different things in the command prompt. So first of all, we're just going to check our Python version. Python and then version. It tells me that I have Python 3.8.1. So if you want to install a newer version, etc., this is maybe a starting point. Now, a big thing that helps you install packages, Python packages, is something called pip, which is short for pip installs packages, so not particularly helpful. But you can look at information of how you install it. You don't already have it on this resource here. And of course, you can upgrade different things. So I'm just going to show an example of how you would upgrade something like pip. So Python, so m pip install u, and then pip. And when you run this, it's going to, so it looks like, so I just did this, so the requirement was already satisfied, so the most recent version of pip was done. If not, it would download the most recent version, and you can do that with other packages. And then if you want to install add-ons, so you can use pip install, and then whatever the package name is, and we'll kind of see examples of that as we go through. I'm not going to install anything today because all the packages I need are already available on my computer. So I'm going to close that down for now. And let's turn to built-in add-ons. So built-in add-ons, they're already available in Python. You just essentially call them in, or usually using the method, or not method, procedure install or import. And so we're going to start with two modules. I guess that would be here, would be the random module and the CSV module. The random module helps generate data randomly, where the CSV module handles CSV files. So I'm going to comment this out first. So we're not dealing with that. So we're going to, to deal with built-in add-ons, you need to start by importing whatever the name is. So you can, for random, you say import random. You can see that import is in yellow, showing that that's sort of a built-in, sort of like the with or for or in. Those are sort of set procedures in Python. So to run this import random, then we're going to create two variables using a couple different methods. So variable A is going to be a random integer using the random, and then dot the method random int, so that's an integer, so that's going to be a whole number. And then we're also going to do a variable called B, which is going to be a normally distributed number using the random.gauss. So Gaussian is another name for a normal distribution. And then we're going to print both numbers by print A, comma B. We're going to run that. It's going to be very simple. And we're going to get 15 as that was variable A, and then 16. See, it's not an integer because it's has a bunch of decimal places. Let's see, if we run this again, it should pull up something different, because each time you're randomly pulling this out from using these functions. So that's a great way to randomly generate data as needed. Okay, I'm going to comment this out. We don't need this now. Now we're going to turn to CSV. So first we had to set our path to wherever we want it to be. So I'm using my temp present folder that I've kind of used for this whole series. We're going to import this add-on CSV. So we're going to do two things. We're going to actually write and read. So we're going to use this format here, where we're going to write a CSV file, and I'm going to call it P9, so Python 9 test. We're going to write, and then new line is going to be set as this, just blank quotes. So with open path, so it looks kind of similar to what we've done before. And then we're doing it as a CSV file. We're going to write this. And so then we're going to have these three lines here. So P9 writer is going to equal CSV writer, the CSV file, and then comma delimiter. And then we're going to write two rows to this. It's going to be row 1, A, B, C, and D, and then some numbers, 10, 15, 20, 25, very, very straightforward. So that's just going to write a file. But then if we want to read a file using this setup, we can use something very similar. We're going to do with open, but instead of having to write, there's just going to be default, and then as CSV file, and then we're going to call P9 reader as CSV reader function. But again, the setup as CSV file and delimiter with comma delimited. And then for row in this reader, we're going to print the row. So when we run this, it's going to be pretty straightforward. The first part is not going to show anything because it's going to write it to a file, but then our reader will read out those two rows. And I think I'm going to go look for the temp present. I'm going to see if I can look for that file we created. So what we call that P9 test. So again, let's create a CSV file, and we'll see the data that we entered in there. So this is an alternative way of manipulating or generating CSV files. And that shows up here. I don't really typically use this way to do CSV files, but this is certainly a format to do that. And you can explore that more if you do a lot of CSV file creation. Okay, so that was pretty straightforward built-in add-ons. I'm going to comment this out, but I'm going to keep path because we'll need that later. Go to built-in add-ons round 2. We're going to take a look at two other modules. There's going to be collections, which is able to store collections of data, and then tkinter, which is good for GUIs or graphical user interfaces with all sorts of different features. you can do buttons, canvases, entry forms, labels, menus, etc. We're just going to do something pretty simple to create a pop-up window with a button. So with collections, we're going to import collections, and then we're going to import a specific module from collections. So from collections, this is to get a specific, I think this is a maybe a function. So from collections, we want specific functions DQ, which is short for double-ended queue. And so, because I think if you just say import collections, it won't know where queue is. So you have to say from the collections import more specifically DQ. And so essentially this just should be a queue that you can, it's able to more easily manipulate it. So like I think of a queue as a list of like a string list. And so we're gonna create a variable called D. So set it to a DQ, so it's gonna be a data type. And we're gonna just start with GHI. And then we're gonna print that to see what it looks like. Next, we're gonna use these methods to append and to the right. So the default appending is to the right. So that's going to put a J after the I. But if we want to append to the left, so on the other end, because this is double-ended, we'll do append left, put F before G. And we'll see what that looks like. Then we'll use these methods pop and pop left to actually take those back out. Popping means like to pop out so that on the right, there's no longer be a J, and then on the left, will no longer be an F. So we'll be back to what we normally were. Print that out to see what that looks like. And we're actually going to use this reversed to be able to take a look at this list and then turn into a list and look at it in the reverse order. And finally, we're going to use this extend function to add again to D, J, K, and L. So we'll run that and how this will pop up. Okay, so first our double-ended queue starts with GHI, and then when we added to each of them, the append, we get F and J here, but then when we pop them out, we go back to the original. And then when we reversed it, we have instead of GHI, we have IHG. And then when we extended with JKL, it now adds out here. So that's a way to, collections is a way to store and manipulate collections of data that maybe is easier, especially if you're doing certain structures than the native Python functions. Okay, we will comment on that. Now let's look at Tkinter. I think that's how you pronounce it. Anyways. So we're going to import Tkinter, and then we're going to create a variable called top that's actually going to set it to the function, a function in Tkinter called, or method called tk. So we're going to set top to tkinter.tk. So whenever time we call top, that's this whole function. And so we're going to run the method main loop on top. And we're going to also import, I don't think I showed this in the description, but sys, that's stuff doing with I think your system. And so, yeah, what actually is happening here with top main loop, we're going to create a blank pop-up window on our computer, and then we're going to use this setup here to deal with, or I think populate that pop-up window. So we're going to use these method system path append. So we're going to need to go to whatever our this is our path. I guess I could have just put path in here because that's what this path goes to. Then we're going to import button, and we're going to need to download a button. So on the Dakota file.doc, we need this button text, and we actually need to save it as a PY file. So I'll kind of show you what mine looks like here, 10%. So I had button.py, original was button.text, and I just, saved as, I forget if I just renamed and then renamed it and then changed this from, text to py. So it needs to be a py file. And essentially it's just some code that we can use to create a button. So we'll need to import button and run py, and then we're going to use run py.run module, and the module name is button. and then we're going to be able to create a pop-up button. Again, some of this stuff I'm just sort of skipping over. This isn't so much, I don't use Tkinter a lot, and it's been a little while, but this should work out. Of course, there's a lot more documentation of if you want to use this, in a slicker fashion. This is more just for example purposes. Okay, so first this has a blank one, so I think I need to close this. And then, okay, now I have this Tkinter button, which is this pop-up, and it has this little button with the exit. And I click exit and it will close it. So it's pretty simple example of this. Probably if you're doing this in real life, you make it a lot more complex and interesting than just a pop-up window with an exit button. But there's an example for you there. Okay, so that concludes our built-in add-ons. Now let's start looking at third-party add-ons. And so for these ones, you will have to have these loaded installed on your computer. So I'll kind of show you what the code will need as we go. So the ones we're going to deal with is NumPy. These are very common or highly used ones. NumPy, which is used for scientific computation, SciPy, which is for scientific analysis, and Matplotlib. So it's a 2D graph plotting library. So to start with, first of all, you need to have installed these. So if you need this, let's see here, command prompts there. So if you haven't already done this, you're going to need to go pip install, NumPy. I think mine should already have done that, but I'm just showing. Okay, yep. See, mine's already here, but if yours wasn't, it would do that for you. So you need to make sure that's installed, and then you can import it. And we're just simply going to create some arrays. So arrays are a data structure. You can think of them as a 1D array is essentially a list. 2D array would be something like a matrix, and a 3D array could be essentially a 3D matrix. And so we're just going to run those and print them, and we're just doing simple numbers. And then it'll print off. This is the 1D array. You see it's just a list 1 through 5. 2D array is sort of a matrix, and then 3D is these two, essentially like a 2D and then another 2D to make a 3D matrix. And that, of course, if you're doing scientific computation, arrays or matrices can be very, very helpful. This is just a very simple, banal example. Okay, next let's turn to SciPy. Again, you'll need to pip install SciPy if you don't already have that. And then we're going to, this is the library, so there's a bunch of things going on. So we're not going to import everything. We're just going to import from SciPy.stat. So that's a subset. We're going to import this function t-test independent. So that's going to be doing an independent t-test. And then we also want to import describe from the same place, SciPy.stats. Then we're just going to create two actually, we'll have to have NumPy already here. I mean, it's already imported, so I'm not going to redo this, but we're actually going to use some functions or some methods in NumPy to create two variables, which are going to both include 100 randomly distributed numbers. So we're going to use numpy.random.normal, and then this setup as size equals 100, so it'll be 100 numbers. So v1, v2. So think of these as two lists of numbers, two lists that you might want to compare to each other with a t-test. So see if the means of these lists are any different. So I'm going to use this stat underscore describe, save call that a variable, and use describe on the first variable. And then we're going to do a variable called test results, which is going to do a t-test individual on these two lists. And of course, you could also, if you really want to do stat describe, you could have another variable that describes list 2, but I'm just doing it for right now, just 1. And we're going to print those out so we can see what happens. And again, this is diving into statistics. I'm not, oh, wait, we do need to have this imported. Okay. what I was saying is with statistics, I'm not going to dive too much into the details of the statistics. That'd be another session here. This is just showing that in Python, you can do statistics. So the printed out description. So this shows a variety of information about this list of 100 random variables. Let's just go to one. Is going to be probably the most useful is the mean. So it turns out the mean of these variables is negative 0.04. So it's very close to one. And other things. And then when we run our t-test result, we get a test statistic and a p-value, and it looks like this is not significantly different. So it looks like the means between these two, variable one and variable two, these lists was not significantly different from each other. And of course, with SciPy, you can do all sorts of things, all sorts of tests. This is a very simple example. I don't typically do statistical analysis in Python, so I'm not expanding too much on this. I'm just trying to show you that there's all sorts of things you can do with it. Okay, and then finally, we're going to do some plotting. We're going to use matplot.lib, and this is this shows off a handy feature of when you import things, you can actually rename them as something a little more doable. So in matplot library or lib, there's a pyplot, I guess, method, but this is a really big, this is pretty long, and I'd hate to have to type this all out every time I did it. So I'm going to import it as, and I'm going to call a name plt, so plot. So when I call plot, it's going to call this whole this larger named function. So first of all, I'm going to use, again, from NumPy, I'm going to create two arrays, X points and Y points. So array is going to be from 0 to 5, and then it's going to be 1 to 100. And actually, we'll print those out to show you what it looks like. And then we're going to use, again, because we've named it PLT, we're going to use PLT and then the method plot to plot the X and Y points, essentially just a line plot. And then we're going to show that. And then that's going to pop up in a new window. And actually, I'm going to comment this out so that doesn't interfere. Okay, I'm going to run that. And that should pop up a new window. There we go here. And this is figure 1. Again, it goes from 1 on the x-axis, 1 to 5, and then from the y-axis, 1 to 100. And then you can save this, do whatever. I think you can configure or zoom all sorts of some functionality here. And you can even kind of see on the x and the y what value is as you move across the plot down in the bottom here. You move your cursor. And to kind of move on to anything else, you'll need to close this figure. And I do want it to look here, see, because I think it restarts you every time, but what did we call this? X, oh, just X and Y. Let's just look at what the values of X is. Oh, I guess that was restarted. Okay, so we can't do that, but that's okay. Oh, right, because X points. There we go, X points. Okay, so it's just an array, Y points, array. Okay, and then if we want to do actually, I'm just going to show you how this works if we have multiple ones. So we're going to now create essentially a bar plot. So we're going to call X an array with A, B, and C as categories, and then Y is essentially these would be means if you're doing actual data analysis, 5, 1, and 7. We're going to do plt.bar instead of plot. They'll do a bar plot rather than a scatter plot, essentially, and then show it. So we're going to run this so it's going to do the first one first. And then I don't think it'll move on until we close it. So that's our first thing we show here. So if we close that, we'll move on and then we'll show us our bar plot. So A, B, and C, and then I think this is 1, 5, and 7. So that's just a simple way to make 2D graphs using matplotlib. Okay, we'll close, comment this out. And we'll move on to the second slew of third-party add-ons. We're going to do a couple things, 4 things here. We're going to use Bokeh for data visualization, Pandas for data analysis, so another way to analyze data, Pillow, PIL for image manipulation, and then Requests for sending HTTP requests. These just, of course, just scratch the surface of the abilities, just kind of show you some examples as we go through here. So start with Bokeh. So this, you'll of course need to pip install Bokeh if you don't already have it. And from this bokeh.io, we're going to import these 2, I guess, methods or functions: output underscore file and show. And then from Bokeh plotting, we're going to import figure. Oh, I guess I need to do these too. And so we're going to, so I think Bokeh visualize data in your browser windows, unlike the pop-ups. So we're going to do a couple different ones. We're going to create a plot called blank figure. We're going to use this figure function, and then an output file called figure.html, which will create an output. So then later you could go back to this and open up in your browser if you want to. And then we're going to actually show the plot, and that should pop it up in your browser. We're also going to do a plot figure with a glyph. And so we're going to create essentially a line that you can, a plotted line. So this isn't blank, and then we can save it as lineglyph.html and then show that. So kind of skipping over some of this stuff under the hood. So this should run, and I think this, okay, this is gonna pop up. Warning, okay, machine. But I think this should still work. Okay, so it's popping up on my side windows here. I'm just gonna get those open and then show those over here. Just give me a moment. Okay, so it saved it as these files. So this is the first one. Just saved it, and I think did it save it in 10%? I'd have to go through. I don't think it's by default saved it at my path. I think you can set that. Otherwise, you kind of need to go just search for it. But essentially, here's the plot. This is a blank plot, so nothing shows up here. We really can't manipulate anything. But then that glyph plot we can see here, and this has a little more functionality. You can move this around and see. I think you can, other things you can kind of play with, but a little more functionality than just using matplotlib, or just a different functionality. All right, so I think I'll close those there. So that's one thing you can do, of course. Next, we'll use pandas. This is for data. Another way to do data analysis, very, very popular. So we're going to import pandas. We're going to create a data set, which is going to have 2 different measurements. So measurement 1, so this is the name of it. So you think of, if you're creating a file, this would be the header. So measurement 1, measurement 2, and then these are the rows with the information. And we're going to call something df1, which is going to be a pandas.dataframe. So a data frame is a type of object that pandas can create that makes it easier to manipulate things. So we're going to print this data frame out to actually see it, and then run a correlation test on it. And so yeah, pandas is a very popular thing to do data analysis. And so you can see here when it prints it out, it's kind of nice how it prints it out. It kind of shows us the measure, kind of like you would do if you'd open up it as a CSV file. Measurement 2, we can kind of see the comparison, and this is the correlation test. And so again, measurement 1 against itself, it's a perfect correlation, but then measurement 1 versus 2, it's about 0.55. That's the correlation coefficient, so they're moderately correlated with each other. So as one is higher, it tends to be higher, one is lower, it tends to be lower. So that's a very minimal thing you can do in pandas. Of course, there's a lot more. All right, and we'll do pillow here. So pip install pillow, comment. And then from PIL, I think that's, yeah, for some reason, pillow isn't called pillow, even though you install it like this, it's called PIL. Anyways, you import this function image. And so what we're going to do here is now you're going to need to have this image to actually manipulate. And of course, you could do whatever you want. I use from Wikipedia here the death of Socrates JPEG, and I have it saved in my path. So that's why I kept where's it, path open. So you'll need to save that JPEG image wherever you have it. So for me, it's in my 10%, and where is it? Did I miss it? The death of Socrates, in it just looks like this JPEG here, but in Python we'll actually open it up as well, or not directly in Python, but use Python to open it. So we're going to use, first of all, we're going to have a variable called image, and we're going to use this image uppercase, case is important, dot open. So we're going to open this and then show it. Then we're also going to create a second image, image 2. We're actually going to rotate the first image and then show that as well. Then we can use a variety of methods, including mod, size, and resize. But the big thing is with resize, we're actually going to make it smaller and then show it and then actually save it as a new resized image. I'm just going to do this pretty rapid fire. But for the first bit, take a little bit. It's going to do some things. It's going to open up this image. Then it's going to open up the rotated image. That's going to be rotated. And then this is our third image, which is the resized one. And actually, I'll kind of want to show you with the resized one. We can see if we zoom in, it gets pretty pixelated right away because it's a smaller image. Whereas if we go back to, so that's the rotated one. But if we go to the original image, you can see if we zoom in here, it's still, it's higher resolution because the image was at higher resolution, whereas the resized one was smaller. So if you wanted to make something like a thumbnail, that'd be a way to do that. So we can see here's the original one, and then we actually saved it, a resized one. I just want to show you the both JPEGs, but can I show you? See here, this one's considerably smaller because we made it a lot smaller. So there we go. So that'd be one step of using and manipulating images. That might be helpful for maybe some of your work. And finally, we're going to do a request. This is a way to request information from places like web pages. So we're going to import requests, and then we're going to set variables X and Y to these HTTP requests. We're going to do, so it's request.get. And so you could do any page. I'm just doing this very straightforward demo page on Python, the W3 schools. I'm actually going to, let's see if I can, I'll show what that looks like, the actual page looks like, so you can see what we're trying to get, and then the biostats page later on. So this is the actual web page. All it is just says this is a test page, whereas this one's the biostats core, obviously a lot more going on. But we're gonna get just the text, so from this page with an HTTP request and print it in Python, and then this is gonna get headers from our biostats page. Okay, and so this gets the text, and this is an HTML, so there's a lot of other stuff going on there, but we can see that we get the text of this which is the only thing here, and then the different HTML information. Whereas this one here, this has stuff about I think what it said, the header. So it gives headers on things like dates and servers and all this stuff. If you really need this for, I don't know, complex web wibbly wobbly stuff. So this is just a again, a very basic example of how to do that. So, all right, so let's comment that out, close that. So we saw how we could use third-party add-ons. So just kind of summarize, there's of course a bewilderingly variety of both built-in and third-party add-ons for Python. And important part is add-ons need to be imported before use, and third-party ones need to be installed before importing and then use. And we just scratched the surface. There's all sorts of references to how to use different libraries, modules, etc., including all the ones we used today, like Pillow, SciPy, etc. That brings us to our lesson 10, stepping out beyond Hello World. We just dealt with add-ons and cracked open the door. You see that there's a wide world of possibilities that Python has. So we'll finish this series by opening the door even wider by showcasing some advanced topics that Python can tackle. We'll look at web scraping, web frameworks, game development, machine learning, and bioinformatics. These aren't all the topics that you could certainly do. These are just some ones that I thought might be of importance. And this isn't going to be any coding, because of course, any sort of these topics is going to take pretty in-depth code. This is just going to be a broad overview and talking about some specific libraries that you can use for these topics. So let's start with web scraping. What web scraping is the collection of data from websites, typically achieved through an automatic process such as a web crawler. So we looked at a little bit of not so much scraping, but getting information from websites back when we used the request import. But there are two very common web scraping Python libraries. There is Scrapy and Beautiful Soup. So Scrapy is widely used for web scraping and other tasks, and it has automatic testing, data mining, and what's called web crawling. And so that's like web crawling is you think of going through a web page and pulling out things. And this is used, the term for like I don't know, it would be like function or code or whatever processes for web crawling it's called a spider. And so Scrapy is good for creating fast and high level spider creation to crawl a website and extract data. So he's using that web page terminology of like web, spiders, web scraping, etc. And on the other side, there's Beautiful Soup, which is also can be used for web scraping, especially good for quick turnaround screen scraping projects. It has simple methods, automated Unicode conversion, and use of popular parsers. So I've used web scraping a little bit, and every time I do a new project, I have to kind of go back to the basics and try to figure out how to do that. So there's a lot that goes into it, but there's a lot of support for these processes. Another thing you can do is web frameworks. Frameworks are software designed to support the development of things like web applications such as web pages, services, resources, and APIs. Two very common web frameworks are Django and Flask. Django is a high-level web framework that generates a variety of websites quickly. It's fast, secure, and scalable with pretty clear and unambiguous documentation, and there's many features for common web development tasks. Flask, on the other hand, is a micro framework aiming at keeping core code simple but extendable. It doesn't make decisions for you, and it doesn't include functions that other libraries already do, so it doesn't repeat a lot of stuff. Now, Flask is great for getting started, but it is hard to create a big website with Flask, whereas Django is better for scaling up. So these have different pros and cons for what your needs are. You can also actually do some simple game development in Python. One such library is Pygame. This is a set of modules for creating video games, especially 2D games. It's simple and easy to use with a lot of functionality, portability, no strict requirements, etc. And you can support a wide range of platforms or operating systems. So if you want to do it in Windows or probably on a phone, if you want to do, Linux, Apple, whatever. And there's many current projects available. So this would be kind of a fun way if you wanted to learn more about Python or developing things, but you don't want it to be the drudgery of like combining lists or transforming data, and you want to do something fun like create like a simple game. This might be an avenue to learn Python. Big topic, machine learning. I'm sure especially that this has become even more of a big topic in the news since I created this slide. But machine learning, simply put, is using computer algorithms to improve automatically by experience and typically with use of training data. Two very common Python libraries for machine learning is TensorFlow. That's the first one. It's a computational library for developing and training machine learning models. It's optimized for speed and has pretty easy model building and walkthroughs for common problems. Keras, on the other hand, is a machine learning for specific for neural networks. So machine learning is a subset of AI, artificial intelligence, and neural networks is a specific method within machine learning. And Keras actually sort of sits on top of other machine learning libraries like TensorFlow or Theano, and so that happens internally. Now it's slower, but very powerful, and it's well supported and deployable. Finally, something that I do have more experience with is bioinformatics. So bioinformatics is the use of computational methods to understand complex biological data, especially genomic information. And the premier library for this is BioPython, which I've used on and off for several years. It is a set of tools for computational molecular biology. It includes parsers for common bioinformatic file formats like BLAST, ClustalW, FASTA, especially use a lot of FASTA, but also things like GenBank. And you can access online services from places like NCBI, like their BLAST, Entrez, PubMed, and you can interface with other bioinformatics software. So common things you might do in BioPython would be like sequence manipulation, annotation, input, output, alignment, and blasting. For example, something I've used a lot with BioPython is accessing Entrez to pull out information on, say, like 16S sequences from bacterial genomes. And so kind of to summarize, Python, we've seen you can do all sorts of things. It's a great tool to have at your disposal, whether you're a researcher, web developer, coding enthusiast, or anyone else. And hopefully through this series of 10 lessons, you've gone from opening Python for the first time to exploring advanced topics, such as, say, bioinformatics or web design. And that these quick guides are not the end of your journey, but the start, to point you the way to wider Pythonic horizons. And with that, actually, wider horizons, here are some resources here. And you should be able to access not screens, what is it? Oh, yes. The PowerPoint slides that have, you can actually go to these links on the Biostats webpage. And with that, I'll have a bit of a bonus. I want to talk a little bit about Jupyter and using Python in it. So Jupyter, there's a couple different flavors of it. So there's Jupyter Lab. It is the more modern thing. It's a web-based developmental environment for notebooks, code, and data. And it's not just for Python. You can actually do all sorts of coding in Jupyter Lab. So think of it as a cloud-based way to create, run, and do things with coding. And then there's Jupyter Notebook, which is the original web application. So it's the simpler one, more classical one than Jupyter Lab. It's used for creating and sharing computational documents. So they both kind of do the same thing. Jupyter is kind of simpler. It's the older one. Jupyter Lab is the more modern one, and it can do more and more bells and whistles. So I'm just going to talk about Jupyter Notebook. I've been trying to do more with both of them. So I learned Python, and I kind of showed you how I learned Python is using the Python and then the scripts, saving and running the scripts. And so that has its benefits, but of course, notebooks have benefits too. And so I'm trying to broaden my horizons. It's a little slicker. There's a lot more slick ways to run it. And so if you're just learning Python now, it might be good to just jump right into something like Notebook or Lab. So and I'll show you how to get to a notebook after you need to, sign up and install things, etc. But I'll show you I'll leave that to you yourself. It's pretty intuitive. If you go to the Jupyter website, you can figure that all out. But once you get this installed and want to use a notebook, it'll show up something like this. And actually, you can access your files on your computer. And then you can create, instead of just Python scripts. They're called IPython notebooks, and they're going to be like your normal code that you can run. And I'll show a quick example here. And it'll show like this. So to actually access the notebooks, this can be through your browser, but you'll need to have something downloaded. So for the notebook, I think it's okay. Jupyter notebook, and you just click and run the app, and then it's going to pop up and do something in the command prompt, the terminal. Going to show. Take a couple seconds here. Okay. Okay, and then it should automatically access, open it in a browser. If not, you can copy and paste this. And give me a second. Here it is. Okay. And so then it opens this up in your browser. And you can see, we always see this. I'm not going to get into all the details here, but essentially you can go and find files and open up and run them just like you would in a script, though with notable examples or advantages. So I'll go to my Python 10 example. I'll show this up here. And what's really nice about these sort of notebooks is sort of, you can create them in chunks and then run them individually, which is really nice, as opposed to saving and running a whole script, as I've been showing you this whole time through, kind of, and if you want to just run chunks, you have to like comment in and out. And so this is a lot slicker way to do things. So you work with this just sort of like you would anything else with Python. You can create variables, you can print them, and then you can run the code, and it'll pop up right here, so you can troubleshoot or look right away. You don't have to wait till the end. So if I just want to show you if it's not all created. Of course, it'll create, if arrows, it'll tell you what your arrows might be, and then go back here, and then you can run this, and you can make sure, okay, it prints correctly. And then you can create other variables, and you can make this as much code as you want. So if you wanted to just chunk all this together, you can certainly do that, or have it separately, really what you want. So it's nice to make things modular and clear. Now you do need to make sure, if you run a chunk that depends on another chunk, to run that chunk first. So if I try to run C right away here, it's going to be an error because B isn't defined yet. Even though it shows up here, it hasn't been run, so that needs to be run. When that runs, that's good. And then so this last little example here, so I create A, which is a string, B, which is a string, C, which is a combination of those two strings, and then I wanted to print 10 times, so it runs here. If I wanted to do it less times, you can modify it, and you can see on the fly. So you can see how that's really helpful to be able to modify and do things on the fly. If I wanted to see, maybe if I wanted to change this, I might have to. Let's see. Give it a second. There we go. So if I want to modify this, I need to run this again, run this one again, and now I'm going to just do this here so I don't have to keep doing that. And I can cut that. You can add things down. It's just sort of playing around. And if I run this, and then okay, that's changed. So notebooks and the lab, they're often pretty helpful. So maybe try that out, and probably if you're learning again for the first time, this might be the way to go to just get used to doing it this way. Whereas I kind of showed you how I did it and how I learn and do most of my thing, because I'm kind of, once you learn something some way, it's easy to get kind of set in it. So it's always a good idea to maybe find the best way to do it right off the bat. But there we go. All right, with that, I think I really truly am done here. Thank you for joining me throughout these Python 10 lunch break sessions. Hopefully this was of use for you. All right, goodbye now.